Every commercial ant killer on the market solves the wrong problem. The ant you see on your kitchen counter is not the problem. It is a scout, a single worker from a colony that may contain hundreds of thousands of individuals living inside your walls, under your foundation, or in the soil around your home. Killing the scout does not reduce the colony by one meaningful unit. The colony replaces it within hours and sends more scouts to investigate the same food source that attracted the first one. This is why the spray and hope approach that most homeowners use produces the same result every summer. The ants come back. Another can of Raid is purchased. The ants come back again. The cycle repeats because the product addresses the visible symptom, the ant on the counter, without addressing the biological structure that produces it, the colony. The pest control industry in the United States generates approximately $20 billion per year, with the residential segment accounting for a substantial portion of that revenue. The products targeting ants specifically represent hundreds of millions in annual retail sales, and the most effective strategy for permanently eliminating an ant infestation costs under $1 and has been documented in entomological research since the early 20th century. The strategy is not to kill ants, it is to kill the colony, specifically the queen. Without the queen, a colony cannot reproduce. Without reproduction, a colony that loses workers through normal attrition collapses within weeks. The mechanism that accomplishes this is a delayed action poison that workers carry back to the colony and feed to other workers, larvae, and eventually the queen before dying themselves. And the substance that works this way has been available at hardware stores in the cleaning supplies aisle for over 100 years. Borax, sodium tetraborate, is a naturally occurring mineral compound that has been mined and used as a cleaning agent, laundry booster, and pest control substance since the 1880s. It is sold under brand names including 20 Mule Team Borax at most hardware stores and grocery stores for approximately $4 to $6 per large box, enough to treat an ant problem for years. Borax works through a specific mechanism that makes it uniquely effective against ant colonies. When ingested by an ant, borax interferes with the insect's digestive system through a process involving the disruption of enzyme activity in the gut. But it does not kill the ant immediately. At the concentrations used in bait formulations, borax kills ants slowly, over 24 to 48 hours. This delayed action is the critical feature. An ant that dies immediately after contacting a poison never returns to the colony. An ant that dies slowly has time to return to the colony, share the bait with other workers through trophallaxis, the mouth-to-mouth food sharing that is fundamental to ant colony nutrition, and allow the poison to spread to workers, larvae, and the queen before any individual ant dies. The bait formulation that exploits this mechanism is simple. 1 cup of warm water combined with half a cup of sugar and 1 to 2 tablespoons of borax mixed until fully dissolved. The sugar provides the attractant. Ants are drawn to high-energy carbohydrate sources and will readily feed on a sugar solution. The borax is dissolved into the solution at a concentration high enough to kill ants through cumulative exposure, but low enough that workers consume the bait freely rather than avoiding it. This concentration balance is critical, and it is where most homemade borax bait attempts fail. Too much borax in the mixture, more than about 1 to 2% of the solution, kills ants too quickly. The workers die before returning to the colony. The bait becomes a contact killer rather than a colony killer. The concentration must be low enough that workers consume substantial amounts and survive long enough to share it widely through the colony before succumbing. The bait is placed in small quantities in shallow dishes or bottle caps near ant trails. It should not be sprayed or spread broadly. It should be placed precisely where workers will find it, consume it, and carry it back. Worker ants carry food back to the colony as a matter of biological compulsion. The bait travels with them. Within days of consistent bait placement, the number of visible ants typically increases as workers recruit more foragers to the food source. This apparent worsening is actually the process working correctly. More workers are consuming the bait and distributing it more widely through the colony. Within 2 to 4 weeks, the visible ant activity begins declining as the colony loses workers faster than it can replace them, and the queen's reproductive capacity is compromised. Complete colony elimination typically takes 3 to 6 weeks of consistent bait maintenance. This is slower than spraying insecticide and watching visible ants die immediately. It is also permanent. The colony is eliminated rather than suppressed. Diatomaceous earth is the second tool in the three-part approach, and it works through a mechanism that is entirely different from borax, and that provides something no chemical insecticide can offer. Diatomaceous earth is composed of the fossilized shells of diatoms, microscopic aquatic organisms whose cell walls are made of silica. When processed into powder, these fossilized shells become an extraordinarily sharp abrasive at the microscopic level. To a human hand, diatomaceous earth feels like a fine powder. To an ant walking through it, it is a field of razor-sharp structures that cut through the waxy layer covering the insect's exoskeleton. Insects maintain their body moisture through this waxy cuticle layer. When the cuticle is cut by diatomaceous earth particles, moisture escapes from the insect's body faster than it can be replaced. The insect dehydrates and dies, not from poisoning, but from desiccation. The process takes hours to days, depending on humidity and the degree of cuticle damage. Critically, insects cannot develop resistance to diatomaceous earth. Chemical insecticides work by binding to specific molecular targets in insect biology: nervous system receptors, enzyme active sites. Through evolutionary selection, insect populations can develop genetic variants that have altered versions of these targets, making the chemical less effective over generations. This is why pest control companies develop new formulations periodically, and why chemicals that worked reliably decades ago sometimes produce disappointing results today. Diatomaceous earth kills through physical abrasion. There is no molecular target to mutate. No genetic variant can produce an insect that is immune to having its waxy cuticle cut by sharp silica particles. Resistance is impossible through evolutionary mechanisms. Food-grade diatomaceous earth, the variety safe for use around humans and pets, is available at garden centers and hardware stores for approximately $8 to $15 for a large bag sufficient to treat an entire home perimeter multiple times. Applied along entry points, the cracks and gaps around door frames, window sills, pipe penetrations, and foundation edges where ants enter the building, diatomaceous earth creates a persistent physical barrier. Any ant attempting to cross the treated area contacts the silica particles, sustains cuticle damage, and dies within hours. The barrier remains effective as long as the powder is present and dry. Rain or moisture reduces effectiveness by clumping the particles, but reapplication after wet weather restores the barrier. Used in combination with the borax bait, the borax eliminates the existing colony from the inside while the diatomaceous earth prevents new colonies from establishing entry points. The two-part approach addresses both the current infestation and future reinfestation simultaneously. Cinnamon is the third component of the approach, and its mechanism is different from both borax and diatomaceous earth in a way that makes it specifically useful as a deterrent rather than a killer. Cinnamon contains cinnamaldehyde, the compound responsible for its characteristic smell, which interferes with ants' chemical communication system. Ant colonies navigate and communicate through pheromone trails, chemical signals deposited by workers that guide other workers to food sources and back to the nest. Cinnamaldehyde disrupts the ant's ability to detect and follow these pheromone trails by overwhelming or masking the chemical signal. Applied as a powder or as cinnamon essential oil at entry points and along ant trails, cinnamon does not kill ants. It disoriented them and deters them from using specific pathways. This makes it useful for redirecting ant traffic away from specific areas: food preparation surfaces, areas where the borax bait has not yet been placed, and locations where you want to prevent foraging while the bait eliminates the colony. A study published in the International Journal of Scientific and Research Publications confirmed that cinnamon oil produced significant repellent effects against multiple common ant species at concentrations achievable with standard essential oil applications. Now let's examine the commercial pest control approach and why it consistently fails to produce permanent results. Professional ant treatment typically involves applying residual chemical insecticides, pyrethroid compounds like bifenthrin, permethrin, or cypermethrin, around the perimeter of the home and in areas of ant activity. These chemicals kill ants on contact through disruption of sodium channels in the nervous system, producing immediate and dramatic visible results. The problem is immediate and dramatic visible results are not the goal. Eliminating the colony is the goal, and pyrethroids are contact killers. They kill what they touch. An ant that walks across a pyrethroid-treated surface dies. An ant that avoids the treated surface survives. The queen, deep in the nest, almost never contacts the treated surface. She continues laying eggs. The colony survives. Moreover, ants detect chemical disturbances through their chemoreceptors and can modify their foraging routes to avoid treated areas. A pyrethroid barrier that initially seems to work often becomes ineffective within weeks as the colony finds routes around the treated zone, routes that were not treated because the ant behavior prior to treatment did not reveal them. Professional pest control operators are aware of this limitation. Many use baiting programs rather than or in addition to perimeter spray treatment. The commercial baiting products they use, Advance Ant Bait, Max Force, Amdro, contain delayed action toxicants in an attractant matrix. The active ingredients include abamectin, hydromethylnon, and indoxacarb, compounds that work through the same delayed colony kill mechanism as borax. These professional bait products cost homeowners between $150 and $300 per service visit and typically require multiple visits. They work through the same biological mechanism as a borax sugar solution that costs $1 to make. The difference is the active ingredient, compounds with patent protection rather than a naturally occurring mineral available in bulk at the hardware store. Here is the practical framework for eliminating an ant infestation using the three-component approach. Start with identification. Different ant species have different food preferences and nesting habits, and the approach should be adjusted accordingly. Odorous house ants, pavement ants, and carpenter ants, the three most common household species in North America, all respond to borax bait, but with different attractant preferences. Odorous house ants and pavement ants prefer sugary baits. Carpenter ants, which are larger and often indicate a moisture problem in the structure, prefer protein-based baits. Combine borax with peanut butter rather than sugar solution for these species. Place the borax bait where ants are actively foraging, along the trails you observe, near the entry points they are using, close to the food sources they have been exploiting. Replace the bait every few days to keep it fresh and attractive. Do not disturb the ant trails while the bait is being consumed. The goal is to let the distribution process continue undisturbed. Apply diatomaceous earth at the entry points around the exterior of the home, the gaps around plumbing, the cracks in foundation walls, the space under door frames. Wear a dust mask during application because inhaling fine silica powder irritates the lungs, even though the food-grade product is not toxic. Apply in dry conditions and reapply after rain. Use cinnamon powder or cinnamon essential oil along interior surfaces where you want to prevent foraging, kitchen counters, pantry shelves, food storage areas, while the bait is working on the colony. Maintain the bait for 4 to 6 weeks, even after visible ant activity decreases. The colony may be significantly weakened but not yet eliminated, and premature cessation allows survivors to rebuild. Here is the synthesis. Commercial ant control products kill visible ants. They do not eliminate colonies. The queen survives. The colony rebuilds. The product is purchased again. Borax bait at 1 to 2% concentration in sugar water exploits the ant colony's own food-sharing biology to distribute a delayed action poison throughout the colony, including to the queen. Complete colony elimination in 3 to 6 weeks at a material cost of under $1. Diatomaceous earth creates a physical barrier at entry points that insects cannot develop resistance to. Cinnamon deters foraging in specific areas while the bait operates. Professional pest control using commercial bait products costs $150 to $300 per visit and works through the same delayed colony kill mechanism as borax, using patented synthetic compounds rather than a naturally occurring mineral. The ant colony does not know the difference between a patented synthetic delayed action toxicant and borax dissolved in sugar water. It responds to a substance that spreads through its food-sharing system and compromises the queen's reproductive function. Borax has been doing exactly that since it was first described in entomological literature over a century ago. If this changed how you think about the ants coming back every summer, hit the like button.